you are looking at the most powerful earthquake ever recorded on the planet Earth. The moment magnitude was a staggering 9.6. But even more shocking than that, it didn't happen on Earth's surface. It happened underneath the ocean. This quake literally shook the foundations of our planet. So what if these quakes were to keep happening? Is the Earth's foundation really breaking? And could we be in for some serious trouble? In this video, we will look at the recent Southern Pacific quakes, figure out why they're so dangerous, and finally determine whether or not they could destroy our world. Now, I don't want to scare you off right away, but when discussing earthquakes, there is no way around this. There are some pretty scary things that go into this natural disaster. So if you're scared easily, then perhaps skip ahead to the next chapter to get to the meat and potatoes of this video. But if you're still watching, then let me paint a picture for you of what exactly happened. On June and July of this year, a series of earthquakes struck near the Kermadec Trench. This trench is located in the southwestern Pacific Ocean and runs for about 720 miles. This stretch of water is where the Earth's tectonic plates known as the Pacific Plate and the Australian Plate collide. Now, to understand what's going on here, we need to take a quick refresher on how earthquakes happen in the first place. Earth's outermost layer, the lithosphere, is made up of several large pieces called tectonic plates. These plates float on the asthenosphere, which has a more jelly-like consistency. As a result, the plates can move around fairly easily. When two plates meet, one can slide beneath the other, causing an earthquake. The point where the rocks begin to move is known as the focus or hypocenter of the earthquake. The point directly above it on the Earth's surface is known as the epicenter. Earthquakes are measured using a device called a seismograph, which records the strength and timing of the waves generated by the earthquake. In 2011, a scale called the moment magnitude scale was developed and became the preferred method for measuring earthquakes. This scale uses the size of the fault rupture and the energy released during an earthquake to calculate its magnitude. So what happened in the Kermadec Trench? Well, due to the fact that New Zealand is located on the eastern edge of the Australian Plate, it is prone to earthquakes. The northern part of New Zealand sits on the southern end of the Kermadec Trench, where the Pacific Plate subducts, meaning it slides underneath the Australian Plate. During this process, the Pacific Plate moves down into the Earth's mantle. This motion causes immense pressure, heat and friction, resulting in massive earthquakes. The most recent example of this is the 8.1 magnitude earthquake that occurred on July. Fortunately, this event happened about 80 kilometers under the ocean floor and 240 kilometers from New Zealand's North Island. However, locals still felt the tremors, and scientists recorded over 100 aftershocks. But what makes these earthquakes so dangerous? Well, there are three main reasons. The first is the depth of the quakes. Most earthquakes happen within 70 kilometers of the surface. Anything deeper than this is considered a deep earthquake. Deep earthquakes tend to have smaller magnitudes than shallow earthquakes because the Earth's inner layers absorb most of the energy from the earthquake. However, because of the immense amount of pressure and heat that builds up inside the Earth, deep earthquakes can still be quite powerful. The second reason is the location of the earthquakes. The Kermadec Trench is located just off the coast of New Zealand's North Island, making it a potentially dangerous location for quakes to occur. The third reason is the rarity of these events. Most scientists only study the data that is available to them. So when something new happens, it can lead to inaccurate predictions and forecasts. For example, before 2011, scientists believed that earthquakes greater than 9 on the Richter scale could not happen because there wasn't enough energy in the Earth's crust to cause such an event. However, this belief changed when a 9.1 earthquake struck Japan in 2011. This event caused a tsunami and resulted in the nuclear disaster at Fukushima. Since then, scientists have begun to realize that earthquakes greater than 9 on the Richter scale are possible. So what would happen if the Earth's foundation was to break? Well, let's start with a little experiment. Let's imagine you're holding a glass of water and you suddenly slam the table, it's on. What happens to the water? Spills, right? That's because the sudden movement causes the water to slosh around, until it reaches a new equilibrium. Something similar happens to the Earth's mantle. If the Earth's foundation was to break, the Earth's mantle would begin to shake and rumble as it tries to find a new equilibrium. This movement would cause massive earthquakes, tsunamis, and volcanic eruptions. Cities would be destroyed and entire countries could be wiped off the face of the Earth. Now let's think bigger. What if the Earth's core was to break? The Earth's core is a solid sphere of iron and nickel. It is divided into two parts, the inner core and the outer core. The outer core is liquid, and it is responsible for generating the Earth's magnetic field. If the Earth's core was to break, the Earth's magnetic field would be destroyed. Without the protection of the Earth's magnetic field, our planet would be bombarded by solar radiation. This radiation would kill all life on Earth and turn our planet into a barren wasteland. So now you're probably wondering, what's the likelihood of the Earth's foundation or core breaking? Well, fortunately, it's very unlikely. The Earth's mantle is strong enough to withstand the pressure of the Earth's core, and the Earth's core is stable enough to prevent the Earth's magnetic field from collapsing. However, there is always a chance that something could go wrong. For example, if a large asteroid was to strike the Earth, it could cause the Earth's mantle to break. Or if a massive earthquake was to occur in the Earth's core, it could cause the Earth's core to collapse. While these events are unlikely to happen, they are still possible. Therefore, scientists continue to monitor the Earth's mantle and core to ensure the safety of our planet. It's important to note that while earthquakes can be devastating, they are also a natural and necessary part of our planet's cycle. They allow energy to be released from the Earth's core and help to shape the Earth's surface. So while it's important to study earthquakes and take precautions to protect ourselves from their destructive power, we should also remember that they are a vital part of our planet's natural balance. And now for the big question, is the Earth's foundation really breaking? Well, based on current scientific evidence, the answer is no. The recent increase in seismic activity in the Kermadec Trench is concerning, but it does not indicate that the Earth's foundation is breaking. It's important to remember that earthquakes are a natural and necessary part of our planet's cycle, and that our planet's core and mantle are stable and unlikely to collapse anytime soon. However, continued monitoring of seismic activity is essential to ensure the safety of our planet and its inhabitants. So while the idea of the Earth's foundation breaking may be a scary thought, it's not something we need to worry about. Just remember to stay informed and follow the advice of experts in the event of an earthquake. And if you want to learn more about earthquakes and other natural disasters, be sure to check out our channel for more videos. Thank you for watching. Keep learning and stay safe. In the last few years, we've seen a growing number of earthquakes in California. Some were small, and some were large enough to shake people awake in the middle of the night. These quakes got me thinking, what if one of those earthquakes was a foreshock, and an even bigger one was on its way? And I'm not the only one who thinks this way. In fact, every major earthquake in California since the 1930s has been preceded by smaller foreshocks. But what does that mean for Los Angeles? Could the big one be on its way? To answer this question, I'll tell you a story about a mysterious earthquake that happened in the middle of the night in 1994. It was a Tuesday. At 4:54 a.m., the earth began to shake. People living in the Los Angeles area woke up in their beds and wondered what was going on. Their homes were shaking violently. Some people thought it was a truck backfiring outside. Others thought it was a transformer blowing up. But when the shaking stopped, they knew something strange had happened. What they didn't know was that a massive 6.7 magnitude earthquake had just struck less than 10 miles north of downtown Los Angeles. It was the largest earthquake to hit the area since 1971. Thankfully, there were no major injuries or deaths, but the damage was extensive. More than 9,000 buildings were damaged, and thousands of people were left homeless. But the biggest mystery was how the earthquake had managed to catch everyone by surprise. It was not a foreshock. No one saw it coming. It just happened. And it got me thinking, how often do major earthquakes happen without warning? The answer surprised me. Since the 1960s, there have been 13 major earthquakes that have hit California without any warning. These are earthquakes that were 6.7 or greater on the Richter scale. In other words, earthquakes that could cause significant damage. Of those 13 earthquakes, only 3 were foreshocks. That means that 77% of the time major earthquakes hit California without any warning. Now you might be wondering why this is important. After all, earthquakes are unpredictable by nature. Knowing that 7 out of every 10 major earthquakes hit the area without any warning should be a wake-up call for us all. We need to be prepared for the worst. Even though we live in an age of advanced technology, we still don't have any way to predict when an earthquake will hit. We can only estimate the probability that one will occur in a certain area over a certain period of time, and even those estimates are often wrong. So what should we do? Well, for starters, we need to make sure that our homes and businesses are up to code. They need to be able to withstand a major earthquake. We also need to make sure that our emergency services are prepared to respond quickly and effectively in the aftermath of an earthquake. Finally, we need to educate ourselves about earthquake preparedness. We need to know what to do in the event of an earthquake and have a plan in place for reuniting with our families afterward. These are just a few of the things we can do to prepare for the next big one. But the reality is that no amount of planning will truly make us ready for a major earthquake. All we can do is our best to mitigate the damage and recover as quickly as possible. Now let's go back to the earthquake of 1994. What was it? A normal fault earthquake or a foreshock? The answer is both. It was a normal fault earthquake that occurred along the southern portion of the San Andreas Fault. But it was also a foreshock to a larger earthquake that occurred a few months later. In January of 1995, a 6.6 magnitude earthquake struck the same general area. It was not nearly as powerful as the January quake, but it did cause billions of dollars in damage. What's interesting is that the January quake was not a foreshock. It was an independent event. The fact that 2 major earthquakes struck the area so close together and along the same fault line was unusual to say the least. Now you might be wondering why this is important. The truth is that we don't really know why 2 major earthquakes hit the area so close together. Some scientists believe that the January quake triggered the January event. Others believe that they were simply 2 unrelated events that happened to occur close together. We simply don't know. Here's what we do know. Major earthquakes can and do happen in clusters. When one major earthquake occurs in an area, it can trigger other earthquakes in the surrounding area. This is known as earthquake clustering. Scientists are still trying to figure out why earthquakes cluster, but they have some theories. They believe that it has to do with the release of stress along a fault line. When a major earthquake occurs, it releases a lot of stress along a fault line. This can cause other areas along the fault line to become more active and increase the likelihood that they will experience an earthquake. What does this mean for Los Angeles? Well, it means that we cannot rely on past earthquake activity to predict future activity. Just because there hasn't been a major earthquake in the last 30 years doesn't mean that we're safe. In fact, it may mean the opposite. The longer the gap between major earthquakes, the more stress that builds up along a fault line, and the more likely it is that when an earthquake does occur, it will be a big one. This is known as the Omori Law. The Omori Law states that the time since the last large earthquake on a fault is a good predictor of the likelihood of a large earthquake occurring in the near future. In other words, the longer it's been since the last big earthquake, the more likely it is that the next one will be big. This is why it's so important that we are prepared for the big one. We don't know when it will hit, but we do know that it could happen at any time. So make sure your home is up to code. Make sure you have a plan in place for reuniting with your family after an earthquake. And make sure you have enough supplies to sustain yourself and your family for at least 3 days. The bottom line is that we need to be prepared for the worst. We cannot afford to be caught off guard by the next big one. Thank you for watching. Keep learning and stay